Welcome to DevNixOps. Look, if you're building or scaling an AI application right now, you're probably incredibly excited about the possibilities. But there's this giant elephant in the room that no one really likes to talk about: the cost. I mean, scaling AI apps is an absolute infrastructure nightmare if you aren't careful. Every single time your app queries a large language model, the meter is running. You're using massive amounts of processing power. And frankly, you're just burning through your budget. But what if a huge percentage of those expensive computations are, well, completely unnecessary? Today, we're going to look at a concept called semantic caching, how an open source tool called BetterDB handles it, and how it can fundamentally change your infrastructure costs. So, are you paying for the exact same LLM call twice? Or maybe 100 times? Or, I don't know, 1,000 times? When you deploy an AI app to the public, you quickly realize that users often ask the exact same questions, just worded slightly differently. Without a smart caching layer in place, your system treats every single one of those slightly varied questions as a brand new, highly complex computational task, and that leads to our core pain point. You are paying expensive infrastructure fees, and you're forcing your users to endure high latency wait times for answers your system actually already knows. It's inefficient, it's slow, and man, it's expensive. Okay, let's dive into this. Here's our roadmap for today's explainer. 1. The AI duplication problem. 2. Enter semantic caching. 3. The e-commerce example. 4. The math of matching. And 5. Slashing latency and costs. Let's get started. Section 1. The AI duplication problem. To really grasp this issue, we have to look at the brutal reality of scale. When you're just testing an app locally, with a few test prompts, hitting the LLM every single time feels totally fine. It's fast enough, and the pennies it costs don't really register. But in production, hundreds of thousands of users inevitably equal hundreds of thousands of identical intentions. Think about it. Human curiosity is vast, sure, but in the context of a specific application, users tend to gravitate toward the exact same core issues. Sending every single one of these functionally identical queries to a raw LLM to be processed from scratch, it's a massive, unnecessary drain on your wallet. It's literally like hiring a world-class chef to cook the exact same bowl of instant noodles a million times a day. It severely impacts your processing speed and creates this incredible infrastructure burden that can just completely destroy your profit margins. Which brings us to section 2. Enter semantic caching. So how do we actually stop paying for duplicate computations? Well, the answer is semantic caching. It's a temporary storage solution that understands the underlying meaning and intent behind a user's question, rather than just matching exact keywords. Standard caching is, a bit rigid. It only works if the user types the exact same phrase letter for letter. But semantic caching uses vector embeddings to understand what the user actually means. An incredibly interesting open source tool that executes this brilliant strategy is BetterDB, which you can actually run right on your local machine to handle this smart memory layer. Let's look at section 3, the e-commerce example. To really cement how powerful this is, imagine massive e-commerce platforms like Amazon or Flipkart. These platforms deal with millions of products, millions of records, and incredibly high volumes of user traffic every single second. And this brilliantly illustrates what we can call the illusion of unique. User 1 asks, "What is your return and refund policy?" User 3 asks, "Can I return my purchase and receive a refund?" Now, to a traditional database, these are completely different strings of text. But human beings use different words to express the exact same semantic intent. BetterDB understands that user 1 and user 3 are asking the exact same thing. So when user 3 asks their question, instead of routing that to an expensive LLM prompt, the semantic cache intercepts it and instantly serves the top result generated from user 1's previous query. You completely bypass the LLM. How cool is that? Moving right along to section 4, the math of matching. Now, what's really interesting about this is how the system actually knows the queries are the same. It all comes down to semantic similarity scores. Think of semantic caching like a highly intelligent bouncer at a club. The bouncer compares the new query to the cached queries and assigns a similarity score. For instance, if a user asks, "What does better semantic do?" versus "What is the purpose of BetterDB semantic?" BetterDB scores that a 97.4% match. Or take, "What are the events conducted in the symposium?" versus "Can you list the events happening in the symposium?" That scores an 87% match. Because these scores are so high, the bouncer lets them skip the LLM line entirely and grabs the answer straight from the VIP lounge, the cache. But where exactly does the bouncer draw the line? According to the source material, BetterDB uses a specific similarity score threshold of 0.5. So if the semantic similarity score between the new user question and a previously cached question is greater than 0.5, boom, it triggers a cache hit. The system decides, yep, these are close enough in meaning and serves the cached answer instantly. This specific threshold is the exact mechanism that saves your infrastructure resources. So let's walk through how this builds into a complete workflow. Step 1, the user asks a question. Step 2, BetterDB jumps in and checks the semantic similarity against past questions. Is it above that 0.5 threshold? If yes, step 3, we get a cache hit. The answer is returned instantly. That means zero LLM cost and near zero latency. But what if it's a totally new question? Well, that's step 4, a cache miss. Only then do we finally prompt the expensive LLM. But crucially, we then save that new prompt and answer into BetterDB so the next user who asks it gets a cache hit. It's a system that continually learns, getting faster and cheaper over time. Finally, section 5, slashing latency and costs. If you're a developer or a business leader, why does this specific implementation matter so much to your bottom line? Well, first, by stopping duplicate LLM calls, you achieve massive immediate cost savings on your AI infrastructure. Second, because fetching from a local cache takes milliseconds compared to waiting for an LLM to generate tokens, you get a drastic latency improvement. I mean, your app feels lightning fast to the end user. Third, BetterDB is 100% open source. And finally, you can deploy it right on your local machine or your own servers. This means you aren't sending your data to yet another third-party API just to manage your cache. You have ultimate complete control over your speed, your privacy, and your budget. Which leaves us with this final thought. Are we moving toward an AI future where smart memory is far more valuable than raw processing power? As LLMs get larger and way more expensive to run, relying purely on raw processing power to answer every single user query is just a losing battle. The businesses that scale successfully will be the ones that leverage semantic caching tools like BetterDB to build highly intelligent, incredibly fast, and hyper efficient memory layers. It absolutely rethinks how we structure AI infrastructure. Thank you so much for joining me on this explainer, and I highly encourage you to go look at how your own applications handle duplicate queries today.